Hi, everybody. Welcome. Good to see you all. Welcome to this first Gonka improvement proposals call. This one is focused specifically on the improvement proposals into the protocol itself. Before we kick off, the scope of today's call are improvements that are major and high priority for the chain for the nearest steps, the nearest updates. So today, the overarching goal and topic of this call would be the steps that we need to take for the network to grow and to scale, for more contributors, for more hosts to join, and for them to be effectively able to run inferences, specifically, but not limited to scaling and sustainably supporting AI engines. So we have 4 proposals suggested to discuss today. We'll kick off with the proposal exactly for scaling the network and supporting more inferences. We have a couple more proposals related to POC updates in order to support different models and small models in particular. And we also have a proposal from Arthur, who'll join later, I think, on deploying larger clusters and prevention of DDoS attacks. So without further ado, let me pass the stage to the first presenter, and Collab will kick off this call with the proposal about scaling the inferences.
Hey, everyone, let me share my screen. Let's start. And first topic is inference scaling. So as we all saw during last months, we have we had a problem when there were too many inference transactions on chain. And right now chain working with additional limits on how many transaction per block, transaction per minute can be created. And that's why exists this concept of allowed transfer agents. And let's go deeper in reasoning of that and how we can resolve it. What is we really recording on chain now? So before we recorded inference payload, so both prompts and payloads were recorded on chain. We moved it from chain couple months ago. Then we still were recording POC artifacts on chain. It was also moved from chain, I think in the beginning of this year. But now we still recording inference metadata. So what is that? Essentially, per each inference we chain compute, there's recorded exactly one message start inference, and exactly one message finish inference transaction, and also some amount of message validation transaction. It can be 0, it can be a lot of them, but let's consider like it's exactly one transaction per each inference. Blockchain based on Cosmos SDK has capacity around 5,000 transactions per block. So we can estimate how many inferences per second we can handle if all these transactions will be just fully occupied block. So for example, for the standard setup for H100 with Queen 235 billion parameters and quite usual inference request, 5,000 input token, 5,000 output token, chain can handle around 300 H100 GPU. So it's quite low, and there are a lot of possible optimization. For example, already now message start inferences are batched for like 30 seconds. Message finish inference are also batched from each participant. But even if optimize it more and even optimize it 100 times more, we still hit the limits quite soon. Let's take a look what can be done with that. So the idea is to move all per request data from the main chain. So not record message start inference, not record message finish inference. That mainnet will not be affected in any way by actually amount of inferences. And per each user, when it started to execute, it started to create inference requests. we create some lightweight shard, and all related transactions and logic will be handled inside this shard. And mainnet then will only process the start of such shard, so put some money in escrow, and then settlement when user either wants to get back money or just it finished. And yeah, so two transactions. It can work something like that. So we have user, we have mainnet, we have some charts which can be implemented in different ways. And user flow will be to send transaction to mainnet to put money in escrow, for example, 100 GNK. Then it gets escrow ID and it gets some group of hosts who will be part of this shard actually. And then user directly communicate with each host in some predefined order with request, for example, chat completion. And it can send any amount of these requests until it still has balance inside this escrow. It can be millions of requests. Then when it's done, it so it sends some settlement transaction back to mainnet and get refund, and host actually get paid. Uh, then yeah, so at mainnet, as I said, we will have two transactions in this way. Message create escrow, which just locks user fund and sample hosts for this shard. For sampling, we can use the slot-based approach, which right now going to be used for POC and already merged in main branch. For settle escrow, user must provide the final usage state of what was used from its escrow, and it must be signed by supermajority of hosts in shard. So it must provide proof that this shard agreed how many coins was spent. Then yeah, each host paid from escrow, remain balance refunded to user. And what is important, it's constant two transactions on mainnet per such session of inferences. Session can be like hours or even days. Uh, what will go, what can go inside chart? I think there are quite important concept to maintain state of such chart per user. So it will be not the like uh, monolithic chain which has all data from different users and can handle any transaction. It's just simple, really small per user state, and there is no transfer agent at all. User directly send execute transaction to host. All transactions are propagated inside this shard without the chat completion request. So for example, user wants to send to get inference from the next host in this group, it must provide all previous transaction with signature, and then state of this host will also be updated. All concept of miss rate, invalid rate, and validation, all everything which we right now has on mainnet will be only inside this chain. And then on escrow, statistics will be provided to mainnet to decide if hosts must be paid or must not be paid. And yeah, and additionally, if user is trying to cheat with such shard, shard can say, oh, we don't agree to sign the final state, and then user just losing full escrow, which it started. Yeah, there is some example how such data will be propagated. So user start with host A, user creates request, send some transaction in diff, then get signature and send request to next host, etc., etc., etc. All concepts which we right now have to handle missed inference and validation will be inside the group, inside the shard, and the shard will decide if increment missed inferences or not. And because this shard is quite small, we essentially can make the process of checking missed inferences or validation much more strict and verify much more data. Because, for example, if we suppose that some inference was not executed, another host in this group can directly go to the host who supposedly not executed request and try to get data from this host, and they can make all this decision quickly because chain is small. So yeah, and all challenges, as I said, will be also inside the shard, and also such shards strictly enforce user to propagate data correctly, to create transaction correctly, because user essentially sequencer in such shard, and it defines the sequence on transaction, and but hosts must sign such state and such transaction to then finalize it, to then settle it. Yeah. So, and what we are thinking about the implementation process of this. The really important step now is in general introduce such primitives. So create escrow, finalize escrow, and at least some way how such shards might actually work. Once we have such primitives on chain, as logic inside this shard will be much simpler than logic of mainnet. We can iterate and change version of such shards much faster, and we don't have to have explicit on-chain upgrade of mainnet, and we also can just maintain different version of logic inside shards simultaneously on chain, and that will allow us to make shorter and uh, faster iterations. Yes. So yeah, and optimistic plan is to propose such changes in the next upgrade and to have some MVP which then can be built to actually have unlimited throw output in terms of inference, so based on only on real GPU. But first release for sure should be quite strict, so such shards also must strictly define limits on how many escrow can be active, how much inferences they can be executed, but these limits are initially should be only to have chain stable and to avoid risk. And also, this process definitely on start must be alive simultaneously on the current way how inference is handled, and then slowly replace current approach with transaction on the mainnet. Yep, I think that's it with idea how scaling can work.
Any questions
Any
or
questions?
comments on this one? I think we have a pretty broad discussion about the necessity of scaling inference and removing this like hard bottleneck of 3 transactions per inference. But yeah, since this is the first proposal, let me also comment that it proposes a general approach, but also the smaller next steps to be implemented. So both can be discussed here and in GitHub discussions. And as long as community agrees that this is the high priority thing, the next thing that we need to implement, we can start getting together, grouping in some smaller teams that can try to implement different approaches for this off-chain process, exactly as Gleb mentioned, so that we can iterate quicker, test it, and check how it works.
My question is, what is how to say, upcoming roadmap for scaling in numbers? Like how many transactions the blockchain will be capable of doing soon, and basically what is the goal for, like, let's say, next half a year?
I think it's impossible to say about the real roadmap because, as we were talking before, we all define roadmap because there are many contributors, many different teams, and it depends on all of us how many real requests will be handled, how many real transactions will be recorded on chain. But closest goal, at least, which I think important for all of us, is to have this kind of broad version of this primitive, which essentially from the first release introduced the concept of only two transactions on mainnet. And then essentially throughput of mainnet will not be blocker right after this primitive is introduced because such shards will be able to scale in some way parallel. So the shards can intersect with each other, but also they can be fully independent for different users. And that means it will be quite easy to scale nodes which execute such shards because, for example, you can run one more small API container, which almost don't need resources. It's like need couple gigabytes of memory and couple cores of CPU and nothing else. And yeah, and essentially if then will be any limits, it can be handled also this way, which is impossible right now with mainnet. And I think that goal is to introduce primitive to allow all this, like as soon as possible. In sooner release, we all must work to propose something like that. But exact numbers, I think, depends on all of us how effective we will be together.
But I mean, correct me because this is like where things getting quite interesting. Currently, I mean, as I understand, only the core group working on this implementation. So I mean, we have resources, but effectively, it's very little information shared how others can contribute to remove this bottleneck. You're referring to all of us, but effectively, I'm just saying it's quite hard to work with a core group because it's very little information shared, I would say.
So
So probably I can reply. So from one perspective, actually, currently, if you look at PRs in GitHub, you will see many various independent contributors put their code in the chain. I think that through the last 2 months, we significantly Gonka experienced significant increase of contribution from many other parties. And this call particular in this type of calls, we hope to have regular so that it's not only in Discord groups or DMs things are discussed, but also I want to have a much broader exposure. And for example, for this proposal, anyone whether on this call or later in Discord, who wants to join implementation, everyone will be able to contribute and be part of it. The idea to more explicitly describe what is possible to implement is actually the center of this initiative. So from this perspective, if you, for example, see one of those proposals important and you want to be part of it, it's quite easy. Just let everyone know in Discord that you want to join, and you will get full exposure to whatever is developed. Moreover, for you who don't know, all the development for every version is actually public in issues in GitHub. So it's another way for you to join and to contribute. You can go to GitHub, see the issues, and just comment in the issues that you want to take the issue, and you will be able to implement it, and you will be able to join the development. So every version, all the work which is done within the version, with the only exception when, for example, some significant vulnerability was privately reported to one of the contributor. In this case, for sure, try to develop it in private, try to find people with whom to discuss this subject, and only publish it as issue or as a PR in the very in the very last moment when we already are close to the upgrade. In all other instances, all the discussions and all the changes are happening in real time in GitHub, in issues in GitHub. So you can filter by the version. For example, currently it's 0.2.11, and you will see all the issues are there. If you have less time, look at the issues which are ready in the PRs which related, and try to contribute by reviewing the PRs. It's also an important contribution. But those calls are like, their primary goal is to actually bring together those people who are ready to actually contribute by implementing parts of those changes, or recommend some of the changes. In terms of number of transactions, in general, what is described in this proposal is removing the main limiting factor which we have right now. We cannot predict it 100%, but we all already saw how similar approach worked with proof of compute. When in the beginning of January, proof of compute would occupy the entire block space. It was like more than 5,000 transactions in the block, and now just 60. Here, what is proposed here, it's even on the higher scale of moving these operations off chain. So my expectation that any implementation of what's described in this proposal will lead us to thousands of transactions, thousands of inference a second, for sure. So it would be much higher than whatever it is right now, and moreover, it will allow or completely utilize the GPUs which right now are connected to the network. Will this approach have some limitations when we talk about hundreds of thousands of inference a second or millions? We will know more after this will be implemented in production, as soon as we'll see some preliminary data. I would say everyone who worked on this project had this experience that some of the things we only can observe in production, even when we test it and measure performance on test nets or through synthetic tests. Still, production is quite different from any synthetic measurements. So I would say that we'll be able to get more of the sense of what would be scale after like first steps of this proposal. But in general, my expectation that implementation such proposal, when we move it off chain, should give us ability to get to 100% utilization of the at least current scale, or like even like couple X scale from what is where we are right now. Gleb, my question, will you share this presentation here for everyone?
Yeah, I will send link.
Please, like if you will have some questions or proposals based on the proposal we just shared afterwards, after this call, please use relevant GitHub discussions.
There's a GitHub discussion, yeah.
Or or Discord. If you haven't found this GitHub discussions, for active development discussions, we want them to be in GitHub. Still, it's all public. The GitHub is public, so you can participate, you can be part of it. But if you haven't found particular issue in GitHub, then Discord will be the best choice. There is a separate channel for improvement proposals. It is where such discussions should take place. If it will be too much within one channel, then we will try to propose some additional channels and additional kind of hierarchy for the discussions.
If there are no more questions about this one, and we are quite dense on time moving forward, let's move on to the next proposal on the multimodal POC. David, that one is on you.
Yes. So this one, can you see the screen? Yeah. This one will be much easier, but I would say that still, like, psychologically, this will have some challenges. I will explain it on the third slide. So as you all know, POC version 2, which was introduced in January, allow us to completely switch to approach when POC model is the same inference model which nodes will use to provide inference responses for completion requests. It actually gives us this beautiful opportunity to actually, without switching between models. So when you enter POC, you don't need to switch model. When you exit POC, you don't need to switch model. You can keep the same model in the VRAM, which remove any kind of blocks in time when actually inference can be served normally. And that's conceptually should allow us to actually run different models on different ML nodes. There are two major issues which we need to solve to unlock that. First is that different models will have different nonce count. And what we should expect is also this difference won't be uniformal. For example, currently with Qwen3 model, which we all run, the nonce count for B200 is almost the same as nonce count for H200. It's not only, it's not like a problem of POC. It's actually, if you will run inference in VLM of the same model, you will see the same results, that the output, the throughput of inference requests will be the same between those type of hardware. But we can introduce new models, like, for example, we all excited about introducing rather like Kimi 2.5 or Minimax. It's definitely one of the top open weighted models right now. And there, the difference between B200 and H200 likely will be quite pronounced. So we'll need to normalize it, but definitely we'll have this problem of different nodes count. Another problem would be with validation bottleneck. So yes, if we assume that each of the participants will run all the models, their voting power can be used to validate any of the models which they run. But it's unlikely. It will be quite a burden on miners to actually have all the hardware to support all the models. And we can get to a place where we don't have actual majority of participants to vote both on POC nonsense validation as well as inference validation, which will which won't allow us to actually claim the immutability, consensus, and all the security measures which we have won't stand the attacks which usually considered to be possible in blockchain networks. So to address those two challenges, the proposal is to introduce these two additional changes. First is nonce normalization for different models. We actually even have already a parameter for the model which can be actually used for this. But still, we'll need to all to test a little bit and to see what is the right model to have. For example, I do think that if eventually for running Kimi for B200, you will have additional advantage, and it will lead to anyone who has B200 to switch to this to switch their ML nodes to this a more powerful model is actually a good thing for the networks. That's why it's actually not really bad for the future of network development to have this discrepancy. But still, we will need to test it properly, to introduce it to the community, and to show the examples before this can go live. The second one is more complicated, and when I thought about proposals which can be made and discussed it with other contributors, we only got to kind of the only proposal which can work is allow delegation. If some of you are familiar with that, in proof of stake networks, delegation is a quite usual concept. When you actually have the stake, but you don't run the validation and you delegate your voting power to some of the validators. So likely we can introduce here a similar concept when a participant can delegate their vote for some particular models which they don't run themselves to other participants. So they will use this voting power to claim some potential attack. So with that, we still kind of, I think that the major psychological issue in this is that it seems that if we only will give it as an option, we won't be able to expect that miners actually will do that. We see that as soon as coins on stake, miners would always, like, even not immediately after upgrade, but next day they will do the action. But without this potential reward or penalty, we see that miners are reluctant to do the required job. That's why the proposal would be to introduce some rewards and penalties to miners who don't either don't have the models themselves, so they cannot use their vote to validate the PoC nonces and inference validation, or if they haven't delegated this to other participants. So at least what seems to be reasonable is to add kind of boost. And this was discussed if you read some of the original proposals, even like when the network only launched. The idea was that if you support all the models, you should have additional boosts for your rewards. And at the same time, likely we'll need to introduce penalty in case when you don't have ML nodes which support the model, and at the same time you haven't delegated your vote for unsupported models, then you need to be penalized. So at least those two things seems to be reasonable to introduce. We also discussed that maybe there is need to kind of reward those who got the delegate, so that miners will promote themselves better, so that people will delegate them votes. So it will be kind of a market-driven rationale to do such activities. And still, we'll need to see in action whether this rewards and penalty will work good enough to actually to gather enough of the voting power for every model which is voted and introduced to the network. So this is the proposal. You can, I will share.
Do you have a quick question or maybe a comment on delegation? I think it makes total sense to reward participants who got the votes delegated, to give them some extra reward, because basically the goal of the network is, the goal of the whole chain is to on the one hand, to have the balance between supporting all kinds of models that we're trying to support and have enough infrastructure, have enough participants who can run this and who can support real users' requests, while actually not dropping the experience for the end users. And yet do it efficiently and emphasize the models that are more popular, so balance this real demand of the models. And with this, the fact that participants who are supporting the hosts who are hosting all the models that they can are contributing into this balance. So I think there should be some natural incentive into doing this, even if it's less profitable for you in other regards, to support a smaller model or like a less efficient, less popular model.
Yeah, smaller models will definitely be a separate topic to discuss.
That's a separate topic.
Other things. Currently, this proposal, if implemented, it will just unlock us to support more bigger models in the network. But if you have any question, I see the question: will the speed of data transfer from RAM become a bottleneck for hosts in the future? In general, in any case, kind of can already affect you, because in general, even when you run just normal inference, it still contribute to the amount of nonces, for example, which you can generate in PoC, etc. But in general, we kind of trying to minimize it, because as I mentioned, with this proposal with PoC v2, it kind of seems to be quite rare case when you actually will need to switch models, and in from this perspective, the model already will be in VRAM, which should remove this bottleneck.
I would even say that as we trying to avoid this redeploy which we had before, it kind of will be good if we right now will see limitations of RAM VRAM, because it will be like real limitations of any inference system, not because of decentralization.
That's true, yeah.
Alexander, I think the important part of delegation is that the current security model support the idea that based on the idea that any PoC weight is actually validated by majority, or now by even super majority of the hosts in previous epoch group. So for example, for epoch group n+1, we have super majority of hosts from epoch n validated PoC. And we want to preserve in general the same rule, that this transition of weights confirmed by majority. And that means that it might be hard to get votes from enough weight of network without delegation. Even if some genesis group is there, to pass this test, this genesis group must have their host weights like more than 2 fidelity of network, which is generally hard to get.
Yeah, original thought was that, okay, like, can we just kind of make it an obligation for miners if they voted for a model, obligation to support all the models. But we will limit ourselves in this way so that like 10 models will be already too much. And so it's for every participant to run 10 models at the same time. But with delegation, yes, you will need to find miners you trust to delegate your voting power to that. And likely will need to set some limitations, for example, that not more than 10% can be delegated to one participant. But in general concept will not change. Okay, let's switch to the next one.
Yeah,
So
let's
if you
move
have
on
any
to the next one.
questions or on proposals or edits to the proposals which you believe should be made, you have this presentation. Please join discussions and let's move forward. If you want to join development, also please let us everyone know.
Note that roadmap-wise, the first thing is to implement the multimodal POC with the LLM, and then like once we have this unlocked, we'll be able to do all sorts of experiments on the delegation and refine this roadmap as we proceed. It's pretty much the plan. And let's move on to the smaller models and to the next proposal on continuous POC. We'll have Gleb and Daniel presenting.
Yep, I will shortly start and Daniel will finish. Could you see my screen?
It's, oh wait, yeah.
Continuous POC, we already mentioned the idea of small models, open question, and there are some specific problems for them. Let's take a look how it works now. So right now, the switch from POC to inference happens like immediately, and once POC started, like in seconds, ML node started to produce nonces. Right now, we have big base model, and more models possible to add with multiple POC. The generation process, the length of generation phase of POC is around 3 minutes now. But let's check what would happen with small models. Small models can have really short time of deploy. For example, it can be not 3 minutes, but 30 seconds. And additionally, to confirm that hardware is still there, that no one kind of tried to remove hardware during inference phase, but connected back to POC. To confirm this by inference only, it will be like huge amount of requests, not even this 5,000, which we consider in scaling, but it can be 100,000. And we should make some work to cover this gap. And until it's not there, we have potential attack when malicious host can so they don't know when continuous POC starts, but they try to deploy such small model when continuous POC already started, and they spend first half of continuous of confirmation POC to deploy this small model, but with a lot of compute, and then they still have time to essentially submit additional nonces and to confirm their full weight. So essentially, until GPU occupied, they are able to have hardware in network only during such confirmation POC. When we use bigger model, there's physical limitation that it's just quite slow to deploy this model. And it's impossible to use this attack because it's just longer than this 3 minutes we mentioned. So what if POC can run all the time in parallel with inferences? So, and generated nonces will confirm weight like in balance with inference. If, for example, 10% of capacity is covered by inferences and confirm their inferences, then host must provide proof with nonces for another 90% of capacity. It will be definitely required some gap to maintain full performance for inferences. But what if design system like that? I think now it's time, Daniel, to continue.
Hello, everyone. Let me share.
Yes.
Now we see it.
So let me talk about the current stack, what we are using in our network, and most of you know that we are using the VLM 0.9.1 and a single model, the Qwen3 that I already mentioned here. And that's like a big plus for the network. We can secure our participants to use the one model to confirm they compute during the epoch, and there's no any problems that happens with the cheaters that we had in the January. And the problem right now is here that one model means a single baseline for both PoC and inference. And we have two states. The first state and when we can handle only inference, and the second when we can compute the proof of GPU, proof of compute of the user. And the problem here is that we need to switch between these two modes and spend a lot of time and block the end user to use our resources to provide the more stable and more good answer to the end user. And the idea right now is to find the way how we can combine these two modes into one, how we can make it during the continuous PoC. And the first step is to switch from the VLM 9.1 to VLM 15.1. It's like a big complex task to upgrade the existing system. It helps out to get better software where we can achieve our result and where we can implement the continuous PoC more easier. Because right now we can use it, of course, 9.1 also supports the scheduler and where we can provide the bit, not great, but the solution, how to support it, but it will be a bit complicated to do it. Hope the next slide is visible. Yeah, what we can do during the continuous PoC. It will allow us to combine the inference and PoC task during one scheduler step. The VLM of 15.1 provides us for us ability to use token budget and use the GPU resources during this step and split the GPU resources to what we need right now. For example, if we have an inference and a couple of PoC tasks, the scheduler will decide what the scheduler should handle the first and what is the second. For example, here in our continuous PoC, we make the inference takes priority. And it means that if the user trying to send the prompt to our network, we make the priority to this inference, and PoC task will not handle until the end user not receives his answer and then get output from the network. And the big plus of this that PoC is the first class task right now. Is the type of request that's handled by scheduler. We don't need to switch between two modes. We don't need to think about key-value cache. We don't need to set up the whole environment around this LLM that the user will use. And it allows us to switch models to provide ability to have more models inside the network and confirm them. And it also provides ability to have ability to confirm their computes during the full epoch. We can execute PoC tasks every time. But it sounds good. And here we have a lot of, not a lot of, but a couple of them a bit complicated tasks. And the challenge is how to calculate the ways that we need to assign to the participant. Right now, it's like we have every epoch, we have the sometimes like sprint before the start of epoch, we have a time where our participants generate the nonces, and then we calculate them, validate them, and assign the weight to the participant node. And the question, the problem here is that it works only without the inference. Here, we need to find a way how to make it more truly, how to make it without, how to do not penalize the user, and to provide a comfortable platform, and how to find the way, how to figure out what we need to do when we have a lot of different models and when we have high traffic to the inference, and we also need to confirm the compute of GPU of each participant. And the problem here is that if just imagine, we have the edge case when the node A calculate produces only nonces, and they will work fast, they will generate a lot of nonces. It will be good for the participant because he can get the more weight than others. Why? It's like a problem right now, because at the same time, node B can have an inference, for example, with the 2000K tokens, and also need to generate nonces. And of course, the half of token budgets, half of GPU resources will be delivered to the inference, because inference is a priority task, and PoC tasks has less priority. It do not handle as soon as possible. And we need to find a way how to compensate the inference during the PoC phase. Like we know that, for example, we know that user already received the inference, but right now we calculating PoC tasks, and it should generate nonces, and we need to find a way how to compensate it. Just one more example. For example, node A generates nonces and 2K token request, and node B can generate nonces and 8K token request, and it will be a more difficult situation, because in this case, one will generate more nonces a bit slowly, but the second one very slow, because we don't have enough resources to generate nodes. And the topics, the general question here, what we can suggest here, which options we have, how to find the good formula to provide the right weight to the user. And like an option, we can measure PoC contribution based on token time or scheduled budget share, not just nonces count. It like I will explain. We can measure how much resources the user spent on PoC, and during this one, find the average number and compensate this average, compensate the inference based on average number. It's like an option, but of course, there is a bit problem, because it's unsecurable. Couple of our participants know how to find a way how to change this data. It's like a bit tricky case how to secure this place. Second option, we can mark inference itself as available contribution and compensate the PoC generation. It's like good option that inference is also part of weight that user can get. We should have a really good network, and inference should be can be a part, and should like of user weights. If user executes or handle a lot of inference during the PoC phase, we need to find a multiplier or find the average value which can compensate. But here is also question how to to find the average value, how to compare the inference, because inference can have different values. For example, the first one is 2K, the second one it's 8K, and if we will have a minimax model, it can be 2000K, and we need to find a way how to calculate how much we need to compensate to the user in nonces and to fill this gap. And probably that's it. If someone can ask a question or have a question for Gleb.
As Daniel mentioned, it's definitely open question how to balance, how to weight different types of contribution, nonces and inferences, and it's hard to solve. And we should be clear that in general, when chain is not fully loaded by inferences, this idea is more wasteful in terms of electricity, because more compute will be used to produce nonces. But in general, with time, the utilization of network by real inferences will grow. Such approach allows to automatically kind of decrease compute used to produce nodes, and percent of used for real work will grow. So it can be less wasteful with time. And additionally, I don't think we in general need and should apply such approach for bigger model chain support. It's essentially needed only for smaller one which are easier to attack.
Should we switch to the fourth proposal?
Yeah, there is one more like broader question in the
Daniel,
chat
will you
about
share the
VLM.
presentation with everyone?
Yeah, I will share.
Yeah, we'll attach all the presentations, post them on Discord, and attach them to the relevant discussions on GitHub. There is one broader question about like general dependency on VLM, which affects all POC really.
One sentence answer. In general, everything designed to have engine easy to switch if it can participate in the same POC and it can be validated. When Gonka launched, performance was almost identical, but VLM was much easier to contribute in. That's why it was chosen. But it's really small changes in base framework, and it's pretty simple to jump from one to another.
Okay. I see one more comment on the bigger models in the chat, but otherwise, if there are no more questions on this proposal, I think we can switch to the next one. Yep. Cool. So the next proposal that we have to discuss is from Arthur here from Hyperfusion about fault tolerance, stability, prevention of DDoS attack, and deploying Sentry clusters. Arthur, you should be able to unmute yourself.
Yeah, that's sure. So hi,
And
everyone.
I'll share the diagram in a sec on my screen.
Yes.
But yeah, sorry, let's go ahead.
Sorry, I'll be a little bit lazy. I'm a road warrior today, so I won't have a very nice and sweet presentation as the other participants did today. However, the topic still is very, very important, and that is something that I can bring from experience of operating big validators with a lot of ML nodes. I think that from epochs around 80, it was public information that we were running one of the top validators at the time. We still do also management of validators with significant amount of ML nodes and significant amount of GPU compute. And this proposal is a combination of suggestions from the core team, as well as observations from our experience on potential enhancements to ensure a more robust solution for individual validators. So the initial problem that we have at this point, and I think that a lot of participants will agree, that there is a single point of failure, and actually there are multiple points of failure that can cause disqualification of validators. One significant issue that I think everybody experienced is the lag of the node container and lagging behind the chain, which causes a lot of effects, including missed inferences, disqualifications during POC, confirmation POC, and that is one problem. A second issue is the API container itself. It also is not fault tolerant. It's not highly available, which also makes it as a target of attacks as well, to ensure that a validator is disqualified. So from a broader perspective, we come to a conclusion that the overall architecture for a single validator should include multiple points of redundancy. The first one is something that can be tackled directly by solutions proposed in Cosmos SDK, which are sentry nodes. This is something visible in this diagram on the left-hand side, where a validator is capable of deploying multiple nodes that are read-only nodes that are public and available for queries for chain RPC. And the second layer, a little bit lower, is a private set of nodes in which a single node acts as the signing node, to which we have the TMKMS connected. So apart from that, apart from building the chain node cluster, we have a second issue with the API container, which expects that it should be polling a single chain node. So the API container itself actually serves multiple roles. One is ML node management and ensuring that ML nodes are acting in the required state. And the second is also serving inference requests and routing inference requests. So to ensure that we have a fault tolerant setup, we should also ensure that the API container is also clusterized and is capable of working with multiple nodes, multiple chain nodes, and to ensure that ML nodes are able to connect to a cluster of API containers to send back POC nonces and also to send back validations. So in this schematic, we can also see that in case an inference request is sent, it is sent to a single API container and then is sent to a single ML node. And this is something that cannot be reserved in a sense because that is a single session. However, for other auxiliary functions, the clusterization of the API container should be pretty much easily organized. I would say it's not a big technical issue. It's more a question of actually ensuring that we don't have states, or if we do have them, that they are shared between API instances via shared cache, something like Redis Memcache, depending on the case. So I would say that from a high-level perspective, that would be it from me, short and sweet. But the devil is in the details, and I'll leave to Gleb or David to probably expand this from a technical challenge perspective.
Yeah. Technical challenges, yeah, as Arthur mentioned, there's open question how to share state between API containers and if it's really needed. And additionally, this public centrist deployment in general will for sure have bigger overhead because it will be several instances, several independent nodes who requires disk space, which requires CPU, RAM, etc., etc., etc. And it's really important to find optimal configuration, which we kind of doing it all right now in terms of how to set up properly pruning, because we all see that some nodes cannot, something is wrong with pruning and disk space just disk usage is really high, but it's not really needed to have any history of states, for example, for private cluster, and they must have everything disabled. But public centers, some of them will be available for users to use RPC port, to use API entry point. and we need to find this balance. So to achieve best performance on the internal cluster, to have all needed data on the external nodes, and there are a lot of details which should be covered there. But in general, I expect that that proposal is already in some parts implemented by different teams, because someone already having two layers like public node container and private node container. Some teams already maintain fully private and not publicly available validators. And we experimented with separate API container which doesn't maintain any ML nodes, doesn't have any ML nodes, doesn't manage them, but still can be used as transfer agent. And as we mentioned early in scalability, the same clusterizing of API containers can be also really important there, because we want to scale this, easily scale this user-specific chain, because there will be no real shared state between them, and there's no need to kind of have any points of failures. Container can be really small, API service can be really small and responsible only for a small subset of users. And yeah, I'm just highlighting here that where we are here. And this part, I think, the easiest one to try to solve from different ways, to try to get small part and try to set up on your cluster already now. Yeah, if you have any question after me.
I would say that one of the last comments here as well is that once we move further away to off-chain transactions and scaling inference with off-chain data and sharding, the availability of the API component will become pretty crucial, especially when we are talking about keeping information about the shard and keeping information about what is the exact subset that it is serving. And in this case, if the API container goes away and does not keep its state somewhere, and we're not talking just about files, that might be a big problem for availability of the overall network.
Yeah, that's true.
Yes, fully agree. And it will require to enable the Postgres for inference payload, which they're already now, to API container, don't store this data locally, to be able several instances of API container to access this data. And it will be really important to try to avoid like having states for all users in single database, because it's again some way to shard and minimize risks. Yeah, so agree. It's quite important to scale it.
Sounds good. If there are any more questions to this or to any of the previous proposals, either make a sign in chat or raise your hand. If not, I think we're getting to the wrap-up point. Yeah. Okay, so then thanks everybody for joining this discussion today. We'll publish the recording of it on Discord. All the discussions are also available on GitHub and on Discord as well. Please continue contributing, continue suggesting and validating, verifying these proposals. Let's get together on the next steps of refining this community roadmap. Yeah, so to reiterate, a lot of these proposals, they show general direction. They identify the big problem that we need to solve and like first very clear steps that we have to do to get there. But then the further we go, the more alternative approaches we can test. And please keep an eye, let's participate, let's have several different teams trying to implement and test something for each of these proposals. I think this will allow us to move faster and to do this better. Yeah, any last comments? Yeah. If not, yeah, thanks everybody for joining, and please continue posting new proposals. We'll have more of these calls. We'll announce, I'm sure we'll announce the next session shortly. So stay tuned for that.
Thank you all.
Thank you.
See you.